I just want to discuss a few more things regarding composition of functions. First, there's another notation that we can use to denote a composition of functions. If we ever have something like f of g of x, another way of expressing this is by saying f of g of x. It's just another notation. This is a little circle. It's not the letter O. It's not a degree symbol because the degree symbol is usually higher, like with temperature or with degrees in an angle. It's just a little circle that goes in the middle. So if we wanted to look at g of f of x in this notation, we could write it g of f of x. We generally put the first part in parentheses, so it's clear that this whole thing is g of f. This is the function, and it's acting on x. So that's one thing. The other thing I want to talk about is the different notations for domains. Notations for domains. We've been using set builder notation for most of the domains that we've been using. However, WebAssign, which is how I assign most of my homework, uses interval notation. And so what I want to do is I want to get a little bit of practice converting back and forth. So I want to look at some examples of domains that we might have in set builder notation and look to see the corresponding interval notation. So we might have something like the set of numbers x such that x is greater than or equal to 3. It doesn't have to be 3, it could be 0, it could be 1, it could be negative 8. But this is one example of the sort of thing we might see for a domain. Now, if x is allowed to be greater than or equal to 3, then if we were to draw a graph of this, we would put a closed circle on 3 and we would shade to the right. So expressing this in interval notation means we'd have a bracket and then a 3, comma, infinity parenthesis, because this interval starts at 3 and goes all the way to the right to positive infinity. If, on the other hand, our domain was x is strictly greater than 3, so it's greater than 3, but it's not allowed to be equal to 3, then we'd have an open circle there and shade to the right, and we would express this as parenthesis, 3, comma, infinity, parenthesis. And if it was less than instead of greater than, x such that x is less than 3, we know we're shading to the left then, and so here we would be going from negative infinity all the way to 3. Now, I want to look at a couple more. We've also seen domains where instead of x being greater than or equal to a number, we had x was not allowed to be equal to a number. So the set of numbers x such that x is not allowed to be 3. In this case, we'd have an open circle at 3 representing that x is not allowed to be 3, but then we would shade in both directions because x can be less than 3 and it can be greater than 3, it just can't be equal to 3. In this case, we have two different intervals that we need to include in interval notation. The left one goes from negative infinity to 3, and then we use the union symbol, and then the right one goes from 3 to infinity. All right. Two more. I want to look at what happens if we have a domain where there are two numbers that x is not allowed to be. So let's say x is not allowed to be 5 and x is not allowed to be 3. Now in this situation, x can be any number except 5 and 3. So on the number line, we're going to have an open circle at 3 and an open circle at 5, but we're going to be shading everything else to the left, to the right, and in between. So in this case, there's 3 different intervals. we've got negative infinity to 3, union 3 to 5, union 5 to infinity. This first one is negative infinity to 3. The middle one goes from 3 to 5, and then the right side goes from 5 to infinity. So in this situation, we needed 3 different intervals connected with union symbols. And then the very last example, we have had several situations where the domain is the set of numbers x, such that x is a real number. In this case, all real numbers are in the domain, and so we shade in the whole number line from negative infinity to infinity. You will get practice using all of these examples in set builder notation and in interval notation in the examples in the videos linked below.